Okay, for those of you listening at home,
These are the notes already.
yeah, I completely forgot to record the first bit of this. The new section is, and I've got a worksheet I'll email to you, called differential equations. The differential is any dy, dx. We've been running into these a lot in the past 4 months. Any equation with differentials in it is a differential equation. And some of them, I warn you, some of them can be really grotesque that you run into in college if you decide to be a math major, or if you just decide to take the course called Differential Equations for fun. Some people do, I understand. Well, I'm an art major, but I'd like to take differential equations just to enrich my mind. Said nobody ever. But it does work. For example, the original problem was dy over dx equals x squared dx, equals x squared. Now that's actually something we've seen before. Technically, in order to take the antiderivative, I want to find y. Let me just cover this up so you don't see the rest of it just yet. In order to find y, I have to get rid of the d in front of the y. The d means a derivative, so I have to take the antiderivative. But I can't take the antiderivative of the right-hand side unless it has a d something, dx, dy, d whatever. So you multiply both sides by dx. The left-hand sides cancel. And now we have something you can take the antiderivative of, and there you go. We tried a version of that with y over x. It was a little more involved, because you have a y rattling around. We got y by itself pretty easily, but you got to get the dy canceled out. You've got to have just nothing but y's. So a single y and no other versions of y anywhere else. And it turns out, with a little bit of that, like you have an advantage of being in a video here. You can go backwards and scroll this. So we just got, I think we divided both sides by dy, and then we just reciprocated the other, both sides. Then we could take, I just rewrote them as 1 and 1. Those are natural logs, and then we just integrate those, and bam. The rest was kind of, this down here was kind of a trick we learned from Newton's law of cooling. It's a exponent rule, like x to the 3 plus 5 is equal to x to the third times x to the 5. That's kind of like what we did here. E to the ln of x times e to the c. And e to the c is just an arbitrary constant. So we'll move that in front, and the rest is history. Okay? Good. You are now caught up. Congratulations. I just handed out a worksheet on differential equations. And it says find the general solution. What that means is find y. You might want to make a note of that on your worksheet. Find the general solution means find y. Let's see if we can do it. If we've got you, I don't want to erase on the blue side. Let me try one that's similar to this. There we go. And there we go. Yes, here's an interesting one. dy over dx equals e to dx minus y. I want to solve for y. The main battle of all these problems, these are called, these are all differential equations, because here's a differential, here's a differential, here's an equation. But these are called separable differential equations. Oops. By separable, I mean you can get all of the y stuff on one side and all of the x stuff on the other. There are problems where you cannot do that. That's what the course in college called differential equations is for. They start covering all the dozens and dozens of ways you can run into things that are not separable and how to solve them. So, idea. One difficult, I mean, there's one thing you can do immediately.
Oh, multiply dx on your side.
Yeah, multiply by dx.
Okay, so I'm talking.
If we just get, it's nice to have a dy on one side and a dx on the other. We'll try that. These cancel. So dy equals e to the x minus y dx. Now again, our battle is to get all the y stuff on one side and all the x stuff on the other. Is that possible?
Can't we change it to e to the x over e to the y?
Yes, indeed. Very clever. E to the x divided by e to the y, that's the next point.
Oh, wow, nice.
dx, now what?
Multiply both sides by e to the y?
Yeah, multiply both sides by e to the y. These cancel. So e to the y dy equals e to the x dx. Go for it. I want y by itself.
You have a big honking log?
No.
Actually, you don't have to.
Or just a medium mocking log.
Well, no.
Or ln. But you
A
do-
big
yeah.
honking ln.
No,
what do you do?
No, there's no big honking.
But you do derivatives, antiderivative on this side.
Yeah, first of all, could you take the natural log of both sides? Yes. Taking the natural log of e to the y will cancel the e.
Oh,
But taking the natural log of dy is a complete mystery. We have absolutely no idea how to do that. So one thing we can do is just take the antiderivative of both sides. Because the dx and the dy are getting in our way. That seems to be the most urgent need. What's the antiderivative of e to the y dy?
e to the y plus 1.
Let's see.
Plus,
Oh,
and I'll call it c1, equals what?
E to the x plus c2.
Plus c2.
I think Ellen just really wanted to say honking.
yeah, I really did.
I'm sure.
It is fun to say.
We can munch these together and get what?
C.
So e to the y equals e to the x plus c plus capital C. Now what?
Do the natural log each side now.
Take the natural log of both sides. So ln of e to the y equals ln of e to the x plus c. The plus c is inside. Now, the left-hand side cancel. Y equals ln parentheses e to the x plus c. Question. Is there, can I cancel the ln and the e?
No.
No. What's stopping?
The plus c.
The plus c. If it were just ln e to the x, it'd just bang bang y equals x. That'd be easy. Is there a log rule that accommodates addition?
Yes.
Like, let me refresh your memory. Actually, refresh my memory. What's the log of AB?
Log a plus b
Log of A
plus log of b.
plus log of B. If you remember, logarithms
Right, slows it
slow
down.
down your function. It takes multiplication and slows it down to addition.
So I don't think addition can be
What
slowed
if you
down.
already have addition? Can you slow it down?
No.
No, it's as slow as you can get. You are done. The plus c stays inside.
Okay.
Questions?
Is it never really helpful to like change it back? Well,
Okay. In other words, would I love to cancel these? Absolutely. This time I can't because the plus c is in the way. Otherwise, yes, I would.
How do we do the back of the sheet?
How do you do the back of the sheet? Excellent question. Just a second.
Kind of.
Station identification.
What do you do when the y has an exponent too? Another one.
Actually, no, that's a dumb one.
just take the square root of it?
Just take
Here's a nice one. I have, is everybody okay with this so far?
Yeah.
And, Emily, you can rewind. We miss having you here, by the way. Let me just copy this one. Do you already actually, this is kind of exciting. Do already x equals, I forgot what was right. 3, yeah. 3 e to the x over y squared, comma, and they say that y of -1 is equal to the cube root of 2e cubed plus 9e squared all over e. The normal reaction to that right-hand side is, I need the facial expression too. You look at this part and you say, yeah, I guess, we can get dy dx. And then you look at this and you, I didn't sign up for this. What is this? It's kind of like saying, here, can you hold this pitchfork? Absolutely. Now here's the 50-foot steel-coated monster. You need to fight it with a pitchfork. Somebody else take a pitchfork. I don't want the pitchfork. So this thing, what are we supposed to do with it? Nothing yet. What they're asking is to find y.
Maybe we don't have this on worksheet.
Find the exact y.
No.
In other words, find any constants. 2. We actually did problems like this about 3 chapters ago, where, a quick example. If I had y prime is equal to 2x, and then y of 3 is equal to 10, can you find y?
Yes.
Try it. Like, ignore this thing. How do you get y?
Well, you would take the antiderivative.
Antiderivative.
So
This,
it'd be-
and y prime is really dy over dx.
Just be x squared.
So I'm going to rewrite this as dy equals 2x dx.
And c would
Yeah.
equal 1.
Antiderivative, y equals, hold on.
What?
Y equals x squared plus c. Does everyone agree with that?
Yeah.
That's just taking the antiderivative of 2x. Can I do better than this?
Yeah. So if you plug
They
in
told
3,
you a hint. Y of 3, in other words, if you plug in 3 for x, you get 10. So 10 equals 3 squared plus c. You can tell me what c is.
1.
Yeah. This is 9. So 9 plus c is 10, so c must be equal to 1. And now you can give me the exact answer. Y equals x squared plus 1. You can nail down the exact equation if they give you a clue. If they give you some sort of plug-in value, that'll tip you off as to what the c would be. That's exactly what they're doing here. It looks scarier and more horrendous than anything we've seen before. But believe it or not, this is kind of like a hint like this. In other words, ignore it for now. I just want to get y by itself. Any ideas? Well, math people.
Well, multiply by y squared and dx.
Yeah, first of all, get the dx on this side, get the y squared on this side. What the technical name for what you're doing, you're separating variables. It's a separable differential equation, so you're separating the differentials and separating the variables so that they're on either side. So I'm going to multiply both sides by y squared. I'm going to multiply both sides by dx. These cancel, and the y squared cancel. You're left with y squared dy equals 3e to the x dx. Okay, looks a heck of a lot better. Now what?
Do the antiderivative.
Antiderivative, as long as you do it to both sides. What does this become? plus, and I'll call it C1, equals what?
3 times e to the x plus c.
Yeah, I'm gonna pull the 3 out. 3 antiderivative of e to the x is e to the x plus c2. And I'm gonna glom these together and just call this c. Let me rewrite that. 1/3 y cubed equals 3 e to the x plus c. Can you get y by itself?
Yeah.
Now, there are two different ways to do this. They give you a starting value, a trial value, if you will. You can plug it in now if you like, or you can wait till we get y by itself. I would actually recommend you plug it in now. In any one. You're gonna have to plug it in for y. Well, actually for x, rather. Oh yeah, no, never mind.
Yeah,
Let's wait till afterward. Just-
Plug it in now.
You can do it now, but yeah, I just realized now that we do. Can somebody get y by itself?
Yeah, multiply by 3 and
Multiply by 3.
Cube
Hang on a
root it.
second. So y cubed is equal to 9 e to the x plus
c.
3c, which is just another version of c. I'll make it a bigger c. And then one more step.
Cube root.
Yeah, take the cube root of this whole mass. The cube root of 9 e to the x, 9 e to the x, plus whatever the c is. The c is inside. Is there any way to reduce that?
Yeah. No.
Unfortunately, no. The plus sign, you might have remembered from algebra 2, plus signs destroy every exponent rule we have. That's why, and this is the nemesis of first year algebra students. Does anybody remember what the most common error is when
But yeah,
they see this?
a squared plus b
They
squared.
assume it's a squared plus b squared.
That's right, I was.
And the answer is no, heck no, never, never, never.
I wish. But
Yeah, it's x squared, it's square the first, double the product, square the last. The plus, if it had been a multiplication, it would work like a charm. That does work, that's a squared, b squared. But addition destroys all the exponent rules we have, including this. You can't separate cube roots unless it's multiplied. If it were multiplied, you can do that all day long. It'd be cube root of this times cube root of c. But we're stuck. So, I'm gonna clear this stuff off. And let's see if we can actually get an answer here. This is gonna be a little intense,
no.
but that's life. Builds character. So we've got y equals the cube root of 9 e to the x plus c. And here's the trial value that they gave us. What are they plugging in for x?
-1.
-1. Basically, the cube root of 9e to the -1 plus c
Equals that.
equals that disaster area.
Oh my gosh.
So here we
Oh
go.
my goodness.
Cube root of 2
So it's not
e to the third
Not
power
be that bad.
plus 9e squared all over 3, or all over e now. What are we trying to get by itself? What's the
C.
only unknown in there? C. So are you ready? Go for it. What do you get rid of first?
The
Cube root?
The
Yeah.
cube root.
so you
Ah,
cube each side.
yeah, cube each side. Now the cube at the top is what?
Is just cancel.
Yeah, those cancel. So it's 2e to the third plus 9e squared over what?
E cubed.
E cubed. Then equals 9e to the -1 plus c. Now what?
Then do you subtract 90 to the -1?
Yep. Let me get rid of this stuff. Got a little more room. Yeah, we need to get rid of the 9e to the -1 to subtract that from both sides. C equals 2e to the third plus 9e squared all over e cubed minus 9e to the negative 1. It might be a real head scratcher as to how to do this. How do you simplify this? Does it simplify? Well, there's one hint. They're asking you to add or subtract fractions. We need a what? Common denominator. Like what?
E cubed.
Yeah. Multiply top and bottom by e cubed. Something rather interesting is going to happen. Can I simplify this? And by the way, I'm going to separate these. 2e to the third over e to the third plus 9e to the second over e to the third. Minus what?
9e squared.
9e squared over
Oh my gosh, they're gonna cancel?
cancel, cancel, cancel.
Wait, what?
E cubed, e cubed.
Oh.
Oh, and there's a 9 here. Oops.
No, that's fine.
This didn't cancel. What did you do?
We got that canceled, right?
Oh, this canceled. These two cancel each other. I was about to say, boy, that's fast. So this looks like
X equals 2?
equals 2.
What the heck?
No,
It's a lot of canceling.
Yep. So here's the original formula. Or here's the original formula. Can somebody give me the final version? Y equals what?
Y equals the cube root.
Cube root of 9 in the x. Got it. If you can do that, you can do pretty much anything I give you on the worksheet.
Alright.
Questions?
That's a roller coaster.
All right, oh yeah. Welcome to calculus. The front page is just plain old differential equations. The back end is differential equations with a specific condition. So on the front page, you're going to have plus c somewhere. On the back side, you're going to find c and plug it back in. Does that make sense? Okay. You have about 22, 23 minutes. The rest of the hour is yours. Go ahead and attack, conquer, be victorious. Tell me every big stack. Otherwise, enjoy. And we'll talk to you again later on. I'll mail you this thing. Cheerio.